I'm Don Farrell. They asked me to host this a little bit tonight. And so this is actually Fuel for Thought, which is a bi-monthly podcast from the Organization of Energy Service Professionals, OESP, that's going to focus on heating topics that matter the most. Each episode is going to feature a practical technical presentation presented by industry experts designed to help you stay sharp, informed, and ready for what's next. And if you miss an episode or would like to watch this one again, the full broadcast is going to be available afterwards at the OESP YouTube channel. You can watch it anytime or share it with your friends and colleagues and family. And again, most of you know who we're speaking with here tonight, but this is Bob O'Brien, if you don't know. And Bob is a well-known expert in all things heating, especially in liquid heating fuels. Bob is currently the president of OESP. He's the director of education for NORA and has owned a very successful heating service company on Long Island, New York for more decades than I think here I would like to admit.
A brief description of biofuel. The topics we did cover were why bioheat, how does it reduce carbon output, what is biodiesel, how is it different from straight number two oil, petroleum, and how to deal with these challenges in the field that you face on a daily basis. Briefly, bioheat is a registered trademark, and it's for a blend of 395 number two oil and 6751 biodiesel. Those are the ASTM specs for those fuels respectively. Anything else is not bioheat. It's a trademark. It would be a bio blend, biodiesel, you can call it whatever you want, but bioheat is a specific trademark for a specific product with only the components of it being biodiesel and heating oil, and both of those having to meet their respective specs. A brief description of what biodiesel is. It's made from soybean fats, soybean, canola oil, UCO, which is used cooking oil, animal fats, chicken from animal processing. It's made by a process called transesterification. It's a chemical reaction. It's a low temperature and pressure chemical reaction. Maybe 10 or 12 years ago, I had a customer who was actually on the east end of Long Island who was making it himself in his garage. It's a chemical reaction. They add lye and methanol to the soybean oil, whatever the feedstock is, the base. And the product that comes out of it is biodiesel, and glycerin is the byproduct. This yields a 50 to 90% reduction in carbon output. And it's not 100% because of the fertilizing, the growing, the energy put into growing the soybeans, crushing it, transporting it, processing it, on and on to get it from the farm in Nebraska to somebody's house in Connecticut. The UCO is at the higher end of that. A lot of that scoring has already been put onto the initial use of it, whether it's for McDonald's or Chinese restaurant or wherever they were frying. And this fuel has to meet ASTM spec D6751, which is the spec for 100% biodiesel. Lately, there's been a lot of talk about renewable diesel. NORA is doing an ongoing field study, both in Pennsylvania and Massachusetts, with a fully renewable blend of biodiesel and renewable diesel. It's the same exact feedstocks, the soybean, canola, animal fat, so forth and so on, but it's made by a process called hydrogenation or hydrotreating. It's a very high temperature and pressure process, typically done in a repurposed petroleum refinery. In Europe, they call it HVO or hydrogenated vegetable oil. Here, we call it renewable diesel or RD. The major difference is, well, two major differences. The big one is there's no oxygen content. Petroleum products are hydrocarbons, just hydrogen carbon, nothing else. Renewable diesel is the same. The oxygen gets stripped out in the hydrotreating process. Biodiesel does have an oxygen component. It's about 9% or so oxygen, and in addition to the carbon and the hydrogen. Renewable diesel meets ASTM D975, which is a spec for diesel fuel. It fits the same exact spec as petroleum diesel fuel. It doesn't need its own. So why biodiesel? I guess the answer is, if not biodiesel, then what is the solution? The industry is obviously under a lot of pressure to decarbonize, and the future is going to be a low carbon future at some point, whether it's 3 years, 10 years, or 30 years. It's eventually we're going to have to decarbonize, and it's really the only practical way for the heating oil industry to decarbonize and meet these mandates and requirements. The mandates right now, as of July, in New York are B10, Connecticut B10, Rhode Island B20. Those states between them are about 35%, maybe a little bit more, of the entire heating oil market in the United States. So it's a pretty substantial market that's already B10 or better. In the future, in 2030, New York's moving to B20, Connecticut B15, Rhode Island B50. That's a big jump there. When these mandates first came out quite a few years ago, 2030 seemed a long time away. Now we're a couple of weeks from 2026, and 2030 is really close. Connecticut will be moving in 2034 to B20 and B50 in 2035. So it's closer than you think. So what's the difference between biodiesel and number two that we're used to? It's more viscous. It's thicker. It's got a higher cloud and pour point. Cloud point is the temperature that wax crystals start to form in the fuel. It'll form at a higher temperature than it does in petroleum. Pour point is self-explanatory. It's the point where the fuel no longer pours. Those are important things to keep in mind. There's slightly less energy per gallon. B100 is about 9%, 8 or 9% less BTUs per gallon. At B20, it's about 2.5%, 2%, not a huge amount. Another difference is when biodiesel is burned, it's slightly less luminous. It emits less light in the range that a CAD cell reacts to. So CAD cell readings are going to be slightly higher with biofuels. And also probably the biggest one is that it contains oxygen. So there's actually oxygen in the fuel. Conventional petroleum is a hydrocarbon, just hydrogen and carbon. Biodiesel is hydrogen, carbon, and oxygen. Real quick, components. So given these mandates and the general move to higher biodiesel content, it makes a lot of sense as you're replacing parts on a rolling basis to use bio-rated components, at least the minimum of what you're using in the state that you're in. The border states to those are also going to see some of it, even though Massachusetts has no mandate. It's bordered by Connecticut, Rhode Island, and New York, and there's a lot of cross-border traffic. So using these things makes a lot of sense at this point. And you can future-proof the industry. We're not going to change 5 million oil filters to bio-rated oil filters today, tomorrow, or next week. But over the course of a number of years, as they're being replaced, if these components were used, when we finally get to higher and higher blends, we'll be set for that. So it's prudent at this point, and even before this really, as you're replacing stuff, new installations, repairs, to use bio-rated components, the highest rating that you could possibly get, but at least the rating is being used in your area. Outside tanks. Outside tanks become a little bit more of an issue with biodiesel because of the higher cloud and pour point. Most important, it's always been important, but it's even more so now, is proper housekeeping and installation. See a lot of tanks back pitched, not pitched towards the outlet. People aren't checking for water. There's traps created. When they run the fuel line off the bottom, they'll create a trap. Numerous issues. Where possible, it's better to go with a single pipe versus a two-pipe system. There's really no benefit to two-pipe other than the self-priming. If that's really an issue to you, you can use a deaerator. But single pipe is better. It's going to cut down the flow rate. The filter is going to see less wax crystals, if in fact there are any there. Filter location is another big one with outside tanks. On Long Island, a lot of outside tanks are on slab houses. And guys will have a tendency where the line enters the house immediately with a Firematic, which that's code, that's where it should be. But since they have the Firematic there, they'll put the filter right after that on a two-pipe system. So now that filter is seeing 18 gallons an hour, approximately, of flow rate, and even a slight amount of crystallization in the tank will overload that filter very rapidly. I've had it where you haven't even put the tools away and it's plugged again. Putting the filter near the furnace boiler, near the appliance, makes a lot of sense. It's a longer run through the house. The fuel gets exposed to the temperature in the fuel line. And obviously having the filter next there, you have a little reservoir next to the appliance, and that's going to heat up over time so the burner sees, hopefully, unclouded fuel. If required, a deaerator, you don't need one everywhere, but where it makes sense, it makes a lot of sense. Additives, the two outside tanks going forward are going to be a chemical solution, additives to reduce the pour point, and mechanical heating, which Nora's done a lot of research into, heating the fuel itself in a tank electrically. So as I mentioned, this is a tank study that Nora did. The lower right, we did this outside on Long Island in 2018 or 2019. Unfortunately, hopefully this year so far looks better. We didn't get a very cold winter, so it wasn't a huge success. So to be able to do the research we needed to do, we rented the freezer, the portable freezer you see on the left, it's actually 20 feet long. It doesn't appear in the picture, but it's quite big. We set up the oil tanks inside that and did numerous tests, no additive testing, just strictly mechanical insulation, enclosures, heating the tank electrically, heating enclosures, insulating the tanks directly, a lot of different stuff. There's a full report up on the NORA website available that delves into it deeper. But as a recommendation, mechanical heating and internal tank heater, they're typically 40 watts and low voltage, or they do make them line voltage and higher wattage. Anything over 40 is going to be line voltage rather than low. Line voltage, obviously, you need a GFI outlet. It's outside, and these are thermostatically controlled. We tested insulating enclosures and jackets, different types. They actually work very well, other than obviously an enclosure can be expensive. It's an investment, and you need whatever you use. It's by code. The tank needs to be inspected. So if it's in an enclosure, a tub, a shed, or something like that, it needs to be able to be inspected. It just can't be sitting there, unavailable for inspection. So this is ongoing research right now in conjunction with SEMA. We're doing research on an external circulation tank type heater rather than inserting the heater into the tank. This heater is actually in the building, and then the fuel circulated with a separate small electrical pump is circulated back to the tank through this heater, keeping the tank above temperature, working out the bugs. It's in the very, very early stages at this point. But that's going to be the project for this winter, and we've had some favorable weather so far, and hopefully it keeps up. That testing was done on B100, by the way. Another issue, or a slight issue that you can have with higher and higher biodiesel blends, is head coking. It typically presents, as you see in the picture on the right, with a varnish type coating, but sometimes it's the typical coking where it gets enough temperature and cooks and turns completely back and hard. Not uncommon, but not particularly common. It's very site specific. Some will do it, some won't, some greater, some more. And it has to do with the distillation curve of biodiesel and the flash point. So the flash point number 2 by ASTM spec is a minimum of 140. Biodiesel, contrarily to that, is 199. So substantially harder. It's somewhat harder to vaporize. If you look at the top one, the little top chart there, the square, that's B100. So you can see it's a higher temperature to vaporize it. And then once it does, it kind of all goes at once and then gradually goes up, versus the heating oil one, which is the black triangle, ULSD. You can see it's a much more gradual curve. The volatiles start to come off earlier at a lower temperature and ignite. It's harder to vaporize, which is one of the reasons people recommend a smaller nozzle size and higher pump pressure. But that's basically the problem. It's slightly harder to vaporize than number 2 oil or ULSD, which are basically one and the same. So what's the solution to this? It's, as I said, it's site specific. It's not every site, every appliance. Some are greater than others. It helps a lot is increasing the pump pressure. Obviously, when you do this, you have to decrease the nozzle size to whatever's required. Fan off delay, some people call it post purge, also helps with that. And number 1, I would say this is the biggest. NORA gets a lot of calls about head coking on particular jobs, and you'll ask for the settings, the combustion settings where they are, and they'll be off to begin with. All of these, this is job 1. Before you get into anything, you really want to make sure that things set up properly. The head settings, Z dimensions, turbulator settings, whatever burner you're dealing with is properly set up to start, and your combustion numbers in line. You're not tremendously lean or tremendously rich, over aired, or too little air on each side. Refractory blankets help somewhat also. A lot of the issue, it seems to be more so in triple pass appliances or any appliance without a chamber, where it's got a cold combustion environment versus a full refractory chamber, warm air furnaces, some boilers. And then you have the pin boilers that are kind of in the middle. They have some refractory, but not a full chamber. They'll be somewhat in the middle. And that heat from that refractory reflects back and helps vaporize the liquid fuel. So in the research we've done, the biggest contributor is cycling. Most of this deposition, the head coking, those deposits are put in during the starts and stops, and mostly on the starts, but for every start, there's got to be a stop, right? The This we do have some control over. So the appliances we're dealing with are single input. It's not like a modulating appliance where we can change the input based on outdoor temperature or load or anything else. Oil burners are either on or off. And unfortunately, people have a tendency to oversize them. Boilers are sized, I would say, double usually, but I mean, it's somewhere in between. So they're oversized. Avoiding that wherever possible makes a lot of sense. And as a throwback, when I first got into the industry, flame retention burners were just taking off, and boilers were tremendously oversized. And there were a lot of coal conversions, a lot of old stuff out there, and people would downsize the nozzle, underfire them. That's something to keep in mind where you can do it, keeping in mind the stack temperature and all the other issues involved with that. The lowest input that'll do the job safely is the best input. It's going to be the most efficient, and it's going to help reduce the cycling. The other issue is the amount of zones. Years ago, 1 zone, 2 zone was common. Now you go into houses, it's 5, 6, 7, 8. They're everywhere. And generally, the houses haven't gotten that much bigger. So a lot of these zones are fairly small. All of these can bring the burner on. A lot of them, if you're using a zone panel, it can bring the burner on, and you'll get a lot of cycling with this. When I first started working for Nora, the general number they used was 10,000 cycles per year, which I thought was a lot. I thought, anecdotally, it was a very high number. But after collecting data, we put counters on it and actually collected the data. That's probably a conservative number. It's probably closer to 12, 13,000 a year. That's an awful lot of ons and offs. And whatever we can do to stop that would be a major help in reducing head coking. Another issue, this one turned out to be less of an issue than it was thought originally. So as I mentioned, flame from biofuel, it's burned, it's less luminous. It emits less light, particularly in the range that a CAD cell reacts to. It doesn't react to all light. So basically, a CAD cell is a resistor. It's a variable resistor, and it varies its resistance in light. And historically, actually probably even less when I started, but 1,000 ohms was considered a poor reading, and probably was. And 1,600 was completely unacceptable. There was an issue there. And with biofuels, that's no longer the case. With B20, typically you'll double the resistance that you would on straight number 2 oil. So if you had an appliance, a pin boiler that's around 400 ohms, it wouldn't be strange to see 800 on a B20 blend with the same burner adjustment, not touching anything else. It's not uncommon to see that. The number one thing with elevated CAD cell resistance is making sure your combustion numbers are in line. Excess air is the biggest impact on elevated resistance. A lean fire, the CAD cell resistance is going to be much, much higher. But seeing on B100, 1,500, 1,600 is not an uncommon number. So is this a reason for concern? These are the posted numbers of some controls. The actual numbers, when you test them, the threshold where they lock out is somewhat higher. So this one obviously is running. You can see the green light on the bottom. And if you look at the ohms, it's about 6,000, 6040. Is that a flame or no flame? Obviously, this control is seeing that as a flame. And as I mentioned, excess air has the largest impact on it. As excess air goes up, resistance goes up. So you want to make sure you're properly set up to begin with. The other issue with CAD cells, they're not scientific instruments. You can get a huge variation from CAD cell, from one to change the eye, change the assembly. You'll get there's a big variation between them. Number one, with elevated resistance, first thing I would do is combustion numbers. Make sure your CO2's in line, your oxygen's in line, that you're in the right spot. At that point, if you're still getting elevated ohms, I would change the eye, make sure the socket's good, make sure the leads are good. A lot of people just change the entire assembly and find it easier, but you can just pop another eye in and try that and see what the difference is. And generally, you see a large variation between them. They're not a scientific instrument. Look at the price of them, and you can see they're not that expensive, and they're not going to be that accurate. Tested obviously all the 3 most popular controls, left them running for 24 hours, and it's burner running. And the same thing with Residio. The threshold on Residio is a little bit lower, but still very substantial compared to the 1,600 or the 3,000, 4,000 that people think it is. It's substantially higher than that. That doesn't mean you want to be running up there. If you are in that range, there's something wrong. But on some units, a triple pass boiler in some burners on B100, you can see in the couple thousand range, and that would be normal for those. This is an interesting chart. I was cleaning my desk a couple weeks ago. I guess it's been a while because this chart was from 1970 from a Honeywell manual, and it gives you the range of the CAD cell. The shaded area is the range that CAD cell reacts to, the resistance range. And really the point of it is it's not linear. If you look at the jump from 100 to 300, it's a pretty substantial jump. And then you go from to 1,000, pretty substantial from 100 to 1,000. But then look at the jump from 1,000 to 3,000, and then 3 to 6 and 6 to 10. It's not a linear progression, right? It's on a slope. So as you get up there, 3,000 is a lot closer to 6,000 than you would think. It's not double. It's closer than that. When you look at the jump from 300 to 1,000 or from 100 to 1,000, they're bigger jumps. So the thing to keep in mind is that it's not a linear progression as they go up. Changing gears here, binding pumps. We've gotten a number of calls. Nora's worked on this probably since 2017, 2018, when it started failing. Pumps would bind, and pump binding is not a normal failure mode. Pumps don't get old and bind. They don't wear out and bind. They do other things, but they don't bind. If a pump's bound, there's a reason for it. If you don't find that reason, more than likely, you're going to be back there. We've heard of spots. The highest I've heard is 14 pumps being changed on one job, but it's quite common to hear of 3, 4, 5. Most often it's water. And the second one would be polymers. Degraded fuel forms a sticky varnish type substance, a tacky substance, gets on the gears and gets on the shaft and binds the pump. You can free it up and it'll work, but generally it happens again. First thing people jump to when it is, and it makes perfect sense. It's the normal conclusion to draw is that it's the fuel. This house is having bound pumps. It's got to be the fuel, and it makes sense. What's the common denominator? Is the same fuel. As we dug into it initially, when Nora first got the complaints, we dug into it, got delivery records from the companies involved, and it's very site specific. So the truck would make 30, 35 deliveries a day. And just this site started with it. And sometimes it wasn't quite right after delivery. And most often it wasn't right after the delivery. It was months and months later, commonly in the fall when the fuel was at its oldest, when it had the longest sitting there and a chance to decay. So it's site specific. There's no delivery correlation. House on a block would have this issue, have 2 or 3 failed pumps. They delivered to another house on this block same day, either before or after, no issues in that house. And 2 houses a block over, no there, and so on, so forth and so on. There was absolutely no correlation between the delivery, the truck, any other factor other than the tank. So in fact, it's a fuel-borne problem. It's definitely a fuel problem, but it's really a tank problem. It's the environment in the tank that's creating this. And until you treat that, it's going to be ongoing. So this is kind of what it looks like. The one on the left is garden variety rust. These obviously have the gear sets removed. You're not going to do that in the field. But if you just pull the strainer and look closely and look at what's there, you can see if it's rust, if it's straight water, or if it's the polymer buildup, like the one on the right, the sticky substance. You can see it kind of looks like a varnish. But you'd want to define what it is. Just because you don't see the rust doesn't mean it's not water. The water in the tank that contributes to the degradation of the fuel and forms the varnish. We had a job on Long Island, a lot of pumps changed there. The tank was in a garage, a detached garage, and the line ran over. It was 2-pipe. The thing bound constantly. They changed pump constantly, nothing but issues. No water in the filter, ever. We went, look at it, same thing. There's no water whatsoever in the filter, yet polymers in the pump, and the pump's bound yet again. Look into the garage. Garage floors are pitched towards the door, obviously. So the tank was heavily pitched away from the top taps. They were top feeding it to pipe. So when we took the FAR plug away from the top tap, there was 3 or 4 inches of water down there. The tank was back pitched towards the front of the garage. And that water acts as a catalyst, as a fuel, as food for the bacteria that live there, and created these polymers, degraded the fuel. And that was the issue. So they got it off a 2-pipe. And waited till the tank ran dry. They had a little bit left, pumped it out, leveled it off again, pitched it the correct way, and this I think was 3 years ago. They had been there, I believe, 13 times over the course of 2 or 3 months. And I spoke to the service manager most recently a year or so ago, and they still have the account and haven't been back since. So another strong correlation with it is two-pipe systems and outside tanks. Mostly common with two-pipe systems and outside tanks. Outside tank, there's not much you can do about it. Two-pipe system, there is. If it's a lift situation, you have over 6 inches of vacuum, you can use a deaerator. If it's under 6 inches of vacuum, you can just switch to single pipe. It solves the problem. Everybody blames it on biodiesel. We've had this happen with B0, which is B5, really. There's not much B5 around anymore. And all of them, some of them have the garden variety rest, but most of them have this varnish on the face of it. So actually, I can take this question right now because it's actually very germane. Scott Nicholas, thanks, Scott. Fact or myth, is biofuel a scrubbing agent? Is the sludge from the bottom of the tank getting scrubbed and causing plug filters and strainers, and sometimes even exposing pinholes in older tanks? Very good question. You hear this all the time. Is it a detergent? The research shows that it's not, but it's more buoyant. So the sludge that's put up into solution when fuel's delivered to it takes much longer to settle out to the bottom of the tank. So it has the same effect. So it may not be chemically a detergent, but it's having the effect of it. So de facto, I guess it is. It's staying up longer when the when the sludge is in solution. It's floating around, and that's can be sucked into the filter, obviously, strainer, fuel line. When it's adherent, when it's stuck to the side of the tank, obviously the filter's never going to see that. We're doing research into it now. Could it expose pinholes in older tanks? It's possible. The jury's out on that. We don't know. We're certainly looking into it. But that being said, if the sludge in the pinhole is the only thing keeping the tank from leaking, that's probably not a good thing either. So, as I said about outside tanks, with all tanks, housekeeping is going to be crucial going forward. Visually inspecting tanks. Tanks leak from rust from the inside out, rarely from the outside in. But visual inspection, if you see any dampness, if there's a wet spot on the floor, you'll see this commonly. Basin's pretty dry. You'll see one little dot or something on the floor under the tank. Where did that come from? You don't want to reach your hand under there. Anybody who's done that knows what happens with that. But yes, we're looking into it, and yes, it does have that effect. People typically say that they have more clogged filters. At this point, we've been B5 since 2012-ish, I believe, in most states. And now we're, higher than that in Connecticut, New York. So it's been quite a while at B5. So I think any effect of that is probably worked through the system right now, although you never know. Situationally, anything can happen. Thanks for the question, Scott. That was germane to what we're discussing here. Anybody has any questions, feel free to pop them in the box there. So obviously you want to check for water all the time. If the filter's properly installed, you can dump the filter canister out, take a look into it. Same thing with the spin-on. You want to dump the filters out when you change them and see what's actually in there, and you get an idea, is there water in there? Is there sludge? Is there anything out of line? So you want to do that every time you check it. Dual filtration has been very successful with it. A lot of people with these situations, especially around 2019, 2020, went to dual filtration with this situation. They've been there numerous times. They changed 3 or 4 pumps. It's cost them a fortune already, particularly if the customer has a contract. Even if not, they're not going to be too happy about paying for 3 or 4 service calls in rapid succession for the same thing. The dual filtration helps quite a bit. Initially, we're using a canister type with a spin-on after it, as you see in the photo. You can use 2 spin-ons. It's very effective. Everything stays clean after that. And getting rid of obviously said the 2-pipe systems, it just overloads the filter. You're circulating a huge amount of fuel through it. And there's really no upside to a 2-pipe other than the self-priming, which obviously a lot of people like, but it's not a huge benefit. Moving on. Oh, I know that guy. Combustion testing. Very important. It's always been important. It's crucial at this point. I'm just going to address Alan's one right now because we're still on the tanks. With regard, Alan Mercurio, thanks, Alan, for the question. With regard to Scott's comment, it's a good reason to talk to the customer at replacing tanks 15 years older, 15 to, I think he left something out there, based on current condition. But obviously, it's a condition-based, and the tanks that fail, rarely are they, 3, 4, 5, 10 years old. Generally, these tanks are 30, 40, 50. I still go out on jobs, not every day, but quite often. And there's a lot of old tanks out there, but inspecting all of them, particularly as they get older, is crucial. A visual inspection, and not all the time. You're always going to have surprises, but you get to see a lot of it. 15 to 20, says Alan. Yes, absolutely. Combustion testing, always crucial. Thank you, Keith. It's always been crucial. It's even more so now. You can't buy a new wet kit anymore, which I guess is a good thing. Bacharach's discontinued it. Unfortunately, they discontinued the draft gauges and the draft right also, which were very popular. But if you want to buy a new combustion instrument, it's going to be an analyzer, which we're a couple of weeks away from 2026 is really the only thing that makes sense. I think using the analyzer, you really have to understand what it does. So they have CO and O2 sensors in them. They're electromechanical. All the other numbers are calculated based on the fuel entered. If you put in number 2 oil or any other fuel, all the numbers other than oxygen and CO are not fuel dependent. It's going to be the same number. It doesn't matter what it's set on. If it's set on natural gas and you're using it on an oil job, oxygen and CO as read are going to be absolutely correct. All the other numbers are going to be wrong because they're mathematically calculated based upon those two numbers. How accurate are they? The AHR spec on handheld analyzers is 0.3% plus minus on O2 and 5% plus minus on CO. So that's pretty accurate considering what the instruments cost and not outrageously expensive. Pretty good accuracy. This is off the track a little bit, but I think it's important to, when you're setting up in combustion, is excess air. Obviously, almost every analyzer gives you an excess air. In this case, we have it set on light oil, the fuel type. So that excess air number is calculated. And excess air is the combustion air surplus to the stoichiometric requirement, which means perfect combustion, which is unachievable in the field. We need a safety margin, and it's typically 30% plus or minus. Some people, if it has an outside air intake, they'll go a little bit lower. Other guys, they like higher. You're in a basement, there's a litter box, there's a dryer, there's a chance of lint or animal hair, whatever. They'll set it up at 35, 38%. And it's directly tied to the CO2. As you can see, at 12% CO2, you're basically 29% excess air, which was generally a pretty decent spot to be. But again, that's calculated on the fuel being used. So the only numbers here that would not change would be the top CO, which is, they call it as read or as measured. That's what the instrument's reading in the flue gas. And the oxygen, the O2. Those numbers are always right no matter what. Excess air and air free and the efficiency are all going to be calculated based upon the fuel, and they may or may not be right depending on you putting in the proper fuel. Air free. So carbon monoxide, as I said, is read by the CO sensor. CO air free is calculated by removing the dilution effect. So the excess air dilutes the sample, which makes the CO look better, right? By removing that, you get a fair comparison. It's not a huge thing with oil burners. With any type of power burner, it doesn't matter the fuel. We're precisely controlling the air into an appliance with an oil burner. An atmospheric gas appliance, for example, doesn't, right? It's open to the atmosphere. The excess air can be tremendously high. We're in a much narrower range. We have very fine control over it. It's part of which makes it more efficient than atmospheric gas appliances. But if you look at this one, you can see the excess air is 26%. So if you knew the CO is 12%, the CO air free is going to be 25% higher than that. In this case, they round it off and it's 15. They're not going to go in, they're not using decimals. But if you look at the carbon monoxide and the excess air, you can calculate what the air free is going to be. So the 15 ppm is calculated as if that 20% excess air was not there, that it didn't exist. Whenever you see a spec on an appliance, when a manufacturer gives a spec, it's always the air free they're talking about. Otherwise, it's just a wild guess. How do they know what the excess air is? So any spec for CO is always an air-free spec. Back to the setting up burners properly is huge, particularly as you can get varying blends going forward. And as oxygen in the biodiesel can have an effect on the combustion process, right? You're either adding or taking away oxygen as the blend changes. It's not going to change it a lot. If you went to B100, it'll change it about 0.4%. So at B10, you're really not going to notice it. The 0.3 of plus or minus on the analyzer, it's really not going to pick up on it. You might get a tenth or two, but you don't know if higher blends are out there. If they're switching, if they buying fuel from a dealer that's selling a higher blend and the house was sold, or you picked up the account, or whatever can possibly happen, that it can change. So I liken it to driving down the center of the road when you don't want to be on the shoulder and you don't want to be on the yellow line. If you're driving down the middle and you get a little variation in the fuel, you're safe and you can handle that. But setting it up properly has always been important, but it's even more so where there can be more variability in the fuel as blends may change going forward from dealer to dealer, and a lot of variables. And it's the safest place to be is set up properly in the middle. So how much difference will it make when you shift up? So this is a chart of excess air at various blends. It gives you both the O2 and the CO2. Obviously, if you look at the O2 across at a certain excess air, it basically doesn't change, right? The oxygen is going to stay the same, but the CO2 is going to move. And it doesn't move a lot. If you just took the 35% column and just went across, you're going from 11.2 to 11.33. These are scientific measurements. These are mathematical calculations. In the field, you're going to get some variability in this, but basically that's it. It's about 0.3 to 0.4% going to B100, which we're not doing. Even at the highest mandated is B20, 11.02 to 11.07. Again, this is mathematically, the analyzers round up, and there's some margin for error there. It could be a tenth or 0.2%. Potentially even 0.3, but that's being the most you're going to see going to a B20 blend. Obviously, New York, Connecticut with a B10, it's going to be negligible. It's within the range. The analyzer is not going to be able to pick up on that. It's too little of a shift. Cold air also makes a difference. And the reason I mention it in conjunction with biodiesel is it's another variability that you have to account for. Where with petroleum, you have a little bit more margin. Now we're going to vary the fuel and we're going to vary the air. It's a lot of things moving. So as most people know, there's less oxygen in cold air versus warm air. There's actually not. Oxygen's 20.9. The density changes. The percentage doesn't change. So thank you for Carlin for the use of this chart. This is from their CAP system, and this gives you the range that you would set up for based on the outside temperature. So you can see on the temperature, you can get quite a range in a shift in CO2, and that's from the density of the air. It's not the oxygen content on a percentage basis. The cold air is much more denser, and you'll deliver more oxygen to the burner. If you could take a combustion analyzer up to Mount Everest and turn it on, it would read 20.9%. Obviously, people die up there from lack of oxygen all the time. The percentage is still the same. There's just not, the density's not there. So it's a density issue. But if you have an outside air intake, it's something to really be conscious of when you set up burners or work on burners, is to take this chart into account. Now you add the variability of the air temperature, and you add the variability of they had B50 last month, and then the house is sold, and 2 months later they're B10. You could potentially get a lot of shifts. So you really want to keep an eye on the air, all the variables in setting up the burner, and air, other than the fuel, air is the only other variable, and particularly cold air. You're bringing air directly into the burner.
Bob, I have a question. You talk a lot about, so much about fuel quality here, obviously. How if I'm out in the field and I have some fuel that I'm questioning, can Nora help me with that?
Absolutely. If you want to send in a sample, if there's a situation with binding pumps, a pump as well as the sample would be preferable. But I mean, if it's just a fuel sample, it's fine. If you have advance notice, we can send you a container and a shipping container to ship it. If not, a clean container, a clean dry container. We get a lot of Poland Spring bottles, Coke bottles, Diet Coke bottles. Unfortunately, they have some residue in there, even if it's water. And the lab test is very, very fine. It can pick up on that. And obviously, if you have a few drops of water in the Poland Spring bottle, and now we say there's water in the fuel, obviously. So if you do use something like that, you want to make sure it's dried out really well. No Diet Coke or Mountain Dew left in it. And there's a form on the NORA website. You can just drop me an email. I'll send it to you. A brief survey form, what the situation you're having. NORA will test the fuel and come back with a report. It's an industry service. There's no charge, to the technician or the dealer for this service. It takes about 10 days or so.
Yeah. I know Ryan Kurz, who is the chemistry
the guru,
engineer, guru at NORA, the barista, so to speak. I think he suggested getting empty paint cans, like Home Depot. They make great shit.
Yeah. Yeah.
The other question I have on that, maybe you know this or maybe you don't. With the studying that's been done so far, is there anything that pops up? Like what are people finding what was Ryan finding when he's analyzing?
Most commonly water is probably the most common. We test for bio content particulates, the solids that are in the fuel. It's centrifuged to drive out all the solids, so all of it gets measured and quantified, and what those solids are comprised of. The ransomat and the acid number, which measures the degradation, the lifespan of the fuel. Every fuel has a lifespan and it degrades over time. And that gives you a number of how old that fuel is and how close it is to the end of its life. Petroleum does the same thing as biodiesel. All fuels degrade over time. And that's basically what we're testing and looking for. Generally, it's water and high particulates. I would say would be 1 and 2. And then biological, bacteria, bugs would probably be number 3. But water's number 1. Sometimes it's not, it's in solution. It's not saturated. It doesn't fall out. So water can stay in solution in both heating oil and biodiesel, and you don't see it until it's put through a centrifuge, which pulls it out.
A great resource. It would really help you.
Yeah, be happy to do it anytime you're having a problem, if you want to try and narrow it down. Also test for bio content.
By the way, the NORA YouTube channel has a lot of instructional videos, also some very interesting videos speaking about the chemistry lab that Bob was just talking about. There's a whole new series of videos behind the scenes at NORA. From what's going on in the chemistry lab and the combustion lab. Some fun stuff to look at. Here's a question. Let's see. Let's go up to this one.
Thanks for the question, Dennis. The question is, I still know techs will not set up burners with analyzers. How do we get this point across and get the companies to ensure analyzers are used? I mean, that's a really good question. I mean, obviously, it's up to the company. I would require a report on each one. I mean, it's only common sense. We're in a litigious society right now. I mean, people sue all the time. And the only way to protect yourself is to have documentation of this. There's Bluetooth analyzers now where you can email reports back to the office. You don't particularly need that printer. Kind of a related point, this was a few years ago. I went on a job and they'd printed out, an analyzer report and stapled it to the service ticket. Unfortunately, it was 600 ppm CO. So obviously they'd given this tech an analyzer and told them to use it and told them to print it and leave it there. But they didn't tell them what the numbers should be and how to get them to where they should be if they're not. So there's twofold to it, but I mean, it's a good question, Dennis, but I mean, obviously the company would have to enforce that. Me personally, I like sleeping at night, and you're in people's houses and you see their kids are playing, sometimes in finished basements right near the boiler, and it's just required at this point. I don't know how to do it. You can bring a horse to water, but I don't know how you make them drink, unfortunately. Our industry doesn't like change. That's absolutely sure. If it was good enough for my grandfather, it's good enough for me. Change is scary for many techs. What else besides presentations like this is NORA doing to get this information out for techs to help with this transition? Another really good question. If you have any input on that, we'd certainly take it. We've done some flyers in supply houses, posters. We have a technical resource center that you can reach by QR code. These posters had the QR code on it that took people directly there. So the the Technical Resource Center it's chapter by chapter, so it's broken up by primary controls, fuels, so forth and so on, following the chapters in the NORA manual. Had a quick QR code and brought you back there where you can get this type of information. So we're doing that. Obviously, articles every month, participating more in social media. I hope people can see that. They've been trying. And obviously this type of stuff and the stuff we're doing with Alan and everything else. But if anybody has any suggestions, all ears.
Yeah. I think I would also add to that the NORA curriculum for the technical schools and trade schools, which encompasses technical schools, high schools, community colleges, trade association schools. The NORA curriculum clearly is all about using modern combustion analysis, or whether you want to define that, not any particular product, but it's a must, and it's in the curriculum for NORA certification.
Just to confirm, what is the scenario where do you want to use 2 spin-on filters in series? Typically, wherever you have a problem, I actually have it in my house. I haven't changed, well, the shoemaker's kids, right? You should change them every year regardless. Mine's probably 4 years old, the second one, but I'm going to change it soon because it's getting cold. But generally, where there's an issue with pump binding or heavy particulates in the tank, the first filter will catch the bulk of it, and the second filter generally stays pretty clean. Line from that point, strainer, nozzle, stays perfectly clean. You can use 2 spin-ons in series, but generally you don't need it everywhere. In the spots that you do, a lot of particulates in the tank, or the problem with the binding. The binding, it'll between that, getting rid of the 2 pipe, the success rate is probably like 98 point something percent. Almost never hear from it again after that. Alan, are canister filter elements approved for bio? No, but the gaskets are. So spin-ons are a superior product, but obviously there's millions and millions of canisters out there. They've been around for, since the beginning of the oil heat industry. They're not going away. But briefly, no. The elements themselves are not approved for bio, but the gaskets are bio. Hey, Tom, thanks for the question. What happens when fuel additives are added? Does it make the shelf life longer? Depending on the additive, yes. Some additives are just focused on one particular facet, and some are, broad-based where they do everything. But yes, if you have something that's going to extend the shelf life, it'll make the shelf life longer. Typically, you want a pour point suppressant that's going to lower the pour point to keep the fuel flowing. Unfortunately, at the moment, they really don't work on the waxing, so the fuel can still stay waxed. But as long as it's above the pour point and can flow and doesn't clog the filter, we're in business, which was the point of moving the filters towards the tank, getting rid of the 2 pipes, slowing down the flow rate, so the fuel, those crystals have a chance to heat up and get back into solution before they hit the filter in the burner. But yes, they do.
Okay, I don't see any more fresh questions.
Nope.
I think I have one, Bob.
Sure.
You were talking about the CAD cell resistance and the readings on the, and you showed a whole bunch of pictures of the controls with the LED readings, and that whatever the CAD cell reading is on the biodiesel, it's well within the range of these newer controls. What happens with controls in the field who are not newer controls? There must be, I can't imagine some out of it.
Yeah, I mean, they're probably okay. I mean, it's a case-by-case basis. So the units that are going to have the highest resistance, typically triple pass boilers, are very unlikely to have a 3-wire control, Honeywell 8184G, for example. That would have the lowest lockout threshold. If you have an issue, it's generally going to be with an older 3-wire control. And at that point in time, Honeywell had the lion's share of the market with the 8184G. I would recommend changing that to a newer control. That doesn't come up that often because generally they're on furnaces and older appliances that will give a better CAD cell resistance than a triple pass.
I imagine there's more than that reason to update that control.
Yeah, I mean, obviously, yeah. You get the diagnostic capability. Years ago, I bought an on-watch for $1,000 to basically, and the time and effort to install it on each job and then go back and get the data and interpret it and then take it off, versus controls that are, a fraction of that, 5% of that do all that did every day, all the time, 24/7. Interrupted ignition. There's just numerous. The newer controls of all three manufacturers are light years ahead. The 3-wire controls are basically obsolete at this point. Scott, another question. Does biofuel affect different kinds of metal? No, but the metal affects the fuel. So the copper acts as a catalyst that can degrade. It degrades all fuels. There's a paper you can find online from the U.S. Navy. They stopped using copper in the 30s in diesel applications because it degraded the fuel. All fuels, petroleum, biodiesel, it's a catalyst. So the copper creates the reaction, but it doesn't actually participate in it. So it's yes, but it's the other way around. The metal affects the fuel, not the fuel affecting the metal. And this other one example, copper, and copper is the perfect example. The copper is a catalyst to the degradation of all fuels, unfortunately. A lot of research has gone into that. And another reason for the two-pipe, there's a lot of exposure time in a two-pipe system. Single pipe, from the time the fuel contacts the copper till the time it's burned, 60 seconds, depending on how long it is, very, very rapidly. We did some research a few years ago, 100-foot rolls of copper, flared the end, plugged it, filled it up with fuel, capped the other end, put it down in the basement in April, took it out in October to simulate the 6-month shutdown you'd get with the heat only or a furnace. And there was really not much degradation of the fuel, but it's the continued contact time. And generally that's not a problem in most applications. Fuel leaves the tank, enters the brass valve, and then into the copper, and then onto the pump in 3-4 minutes, 8 minutes, very short period of time.
So let me ask you another one then. And forgive me if I'm you're going to have to repeat yourself, but you were talking about head cooking.
Yep.
And it's just, I know it's a stubborn issue with certain applications, and it's a little bit because you think you can do to remediate it. But at what level of biodiesel does that start to rear its ugly head, so to speak?
You can see it in certain appliances. It could be at relatively low blends, B20 or so. And it also depends upon the time frame. If it's been serviced annually, it's really probably not an issue. It's geared towards it's basically refractory and cycles, a combination of those two. If the unit has a full refractory chamber, it's going to be relatively mild. That refractory radiates the heat back onto the droplets coming out of the nozzle and helps vaporize them, so they burn faster. It doesn't stay in that liquid state for very long. Other appliances without it, it could be substantially more, but generally around B20 or so. You may see it in some applications. B50, it becomes a bigger issue, but it's very site specific. There's certain applications. We've been doing B100 field testing for 7 years now, and some of them it's fairly substantial, and a lot of them it's not at all. Yep. There's Wayne. Thanks for the input, Wayne. So he works for a very big company, and they're at B20. And you'll see it in some spots, and you won't see it in others. But I mean, all of Rhode Island's on B20 right now, and I'm sure they're seeing it in some and not in others. And generally, it's correlated with whether there's refractory or not, and how often the burner is cycling. We are using another question for Wayne, thanks. We are using B20 outside. Above ground tanks in the cold are an issue. I'm guessing that's a statement and not a question. And it can be. I mean, obviously we had, it was pretty chilly here last night. We're going to have some cold weather upcoming too. I'm hoping it's going to be a cold winter. I started in the late 70s and tank froze then with no one even heard of biodiesel all through the 80s into the 90s, and no one ever heard of biodiesel. So gelling's always been an issue. And generally, everybody knows their problem tanks. I knew the ones that every year it was the same issue. And you really want to be proactive with those. Insulating the fuel lines, if you need mechanical heating, additives, whatever it takes. But yes, could B20 be a problem? The 20% of it that has a higher cloud and pour point than number 2 could definitely be a problem with outside tanks. We were probably in the low teens last night.
Getting back to the coking question,
That's Scott from Scott Nicholas. Wouldn't higher temp rise and boiler temps contribute to that coking? You would think so, but it doesn't. It actually helps vaporize the liquid droplets as they're leaving the nozzle and reduces it. So the coking is unburned fuel that's being pulled back onto the head. So a flame retention burner, that it's got a lower pressure zone, right? It's what makes it flame retention. That's what keeps the fire there. It's lower pressure. Um, you would think that, but it doesn't. Kind of like nozzles, where a higher viscosity fuel actually flows more through a nozzle and less. Common sense would lead you to believe it would flow less, but in fact, the way the swirl chamber is designed, it actually flows more. So yeah, it's counterintuitive, but the higher temperature, hotter flame, hotter refractory, focus back, actually helps vaporize the fuel so it doesn't come back in a liquid state and land on the head. That dark, tacky stuff is unburned fuel hitting the head and then sitting there and coke, and then eventually it turns black. Wayne's absolutely right. Dropping the nozzle size, increasing the pump pressure works in a lot of applications, and most it does. The problem is we've tried a ton of different things, and they all work to one degree or another, but none of them is the magic bullet yet. I don't know if there's going to be a magic bullet. It may be an all of the above solution, or it may be, on these kind of boilers you do this, on these kind of furnaces you do that. But generally, yeah, higher pump pressure works. Smaller droplets, better atomization, so it's easier to vaporize a smaller droplet liquid than a bigger one. Got another question from Albrita. What advantage any would pre-purge and post-purge help with the coking? It cools down the head. So the coking actually, so it hits the head in that liquid state, and then the heat radiating back turns it to coke, the black stuff that you generally see. It cools down the head. It also keeps the electrodes clean. Biodiesel degrades differently. So if there's a slight after drip, I'm sure people have worked on jobs with higher bioblends have noticed the carbon deposits in the bottom of the tube, not even out near the head, sometimes fairly far back. And the heat there is kind of cooking the biodiesel and it degrades like that. So it's cooling the head and stopping the fuel from coking, and hopefully it can burn on the next startup is the answer to that. So yeah, that one's kind of counterintuitive too, but it does help.
Great questions, by the way, guys. I always learn a lot myself on these things. I always learn a lot every time I talk to Bob, too, as you can imagine. Bob, why don't you tell us about our next Fuel for Thought?
The next session is going to be Monday, January 12th, and our guest will be Alan Warnham of R.W. Beckett. And we're not sure of the topic yet, but it's definitely going to be technically based.
We're at an hour, a little bit over an hour, which is what we were scheduled for. And in the absence of any further comments or questions, Bob, maybe we can wrap up the first issue of Fuel for Thought.
Sounds good. I wanted to thank everybody for coming. I hope you enjoyed it, and thank you again for coming. Hope we'll see you next month too.